So, good afternoon, everyone. Today we are going to start with another topic. It's called object-oriented. Why do programmers prefer dark mode? Because light attracts bugs. What did the object say to the class? You're my type. Why do programmers prefer oops? Because it's a class act. What do you call an object that's feeling sad? A depressed instance. Why did the programmer quit his oops job? He didn't get a raise. Why did the programmer quit his oops jobs? Why do oops programmers love inheritance? Because it's a family affair. What do you call an object that's always changing? A variable personality. Why did the programmer use oops? To encapsulate his secrets. What do you call a class that's always helpful? A utility class. Why do the oops programmers love polymorphism? Because it's a shape shifter. What did the object say when it was instantiated? I am alive. Why do programmers prefer oops languages? Because they are objectively better. What do you call an object that's always in control? A master object. Why did the programmer use abstraction to hide the details? What do you call a class that's always organized? A structured class. Why do OOPS programmers love composition? Because it's a composite solution. What do you call an object that's always interacting? A collaborative object. Why did the programmer use inheritance? To build a family tree. What do you call a class that's always flexible? A dynamic class. Why do OOPS programmers love encapsulation? Because it's a wrapper. What do you call an object that's always unique? A singleton object. Why did the programmer use polymorphism? To adapt to changing situations. What do you call a class that's always efficient? An optimized class. Why do OOPS programmers love objects? Because they are tangible. What do you call an object that's always consistent? A predictable instance. Why did the programmer use OOPS principles? To create a solid foundation. What do you call a class that's always reusable? A modular class. Inheritance allows us to create a new class based on an existing class. Encapsulation helps hide the implementation details of an object. Polymorphism enables objects to take on multiple forms. A class is a blueprint for creating objects. An object is an instance of a class. Objects have properties and methods that define their behavior. Inheritance promotes code reusability. A subclass inherits the properties and methods of its superclass. Inheritance helps create a hierarchy of classes. Polymorphism allows for more flexibility in programming. Method overriding is a form of polymorphism. Method overloading is another form of polymorphism. Encapsulation helps protect an object's internal state. Access modifier control access to an object's properties and methods. Encapsulation promotes data hiding. Abstraction helps simplify complex systems. Abstract classes provides a partial implementation. Interfaces define a contract for implementing classes. Object-oriented programming promotes modularity and reusability. OOPS helps create more maintainable code. OOPS enables developers to model real-world objects. Tight coupling can make OOPS code harder to maintain. Overusing inheritance can lead to complexity. OOPS requires careful design and planning. Follow the solid principles for good OOP design. Use inheritance widely to avoid tight coupling. Encapsulate data to protect it from external interference. Hello everyone. Today we will explore object-oriented programming, the style of programming that models real-world objects, like a car, bank account, or a student. The next topic is called OOPS concepts. We have OP concepts. So there are primarily four parts here. So the first one is called encapsulation. Then we have inheritance. Then we have polymorphism. And then finally, we have abstraction. So encapsulation is about binding data and methods together in what we call as a class. So we'll discuss this later. Inheritance is basically to reuse by deriving new classes. So we reuse already existing classes, existing classes. Then you have polymorphism, which is a same function that behaves differently. So that is polymorphism. And then you have abstraction. So abstraction is hiding details to show only the most essential ones. So these are the four main concepts that you need to make a note of. So next we have a simple OOPS example. So a simple example. So let's jump into our code editor now. So in Python, what you can do is basically, firstly, let's say a simple object-oriented programming example is basically we can create a class called animal. And remember, classes are basically like saying it's basically like a category. So that's what we are creating here. So class animal is what we have. And inside of this class, there will be multiple functions, right? So you know what a function is, right? A function basically is anything that takes in an input and gives an output, right? So we define in Python, we define function as def of inputs, right? And we have to specify a return, right? So return will basically give out the output. So that is what we have as a function. So function f of x takes in an input and gives out an output. That is what is the simple, uh, you know, simple definition of a function. Now let's say we take the example of this simple uh, object-oriented programming example. So here we define a class called animal, right? And then we inside this we define a function called speak, which takes in the self input, and then we print out uh, animal sound, right? So can you tell me what this function does simply? I think you guessed it right. So basically this function, what it does is it basically prints out the animal sound. That is what it does. Then what we can do is, now once we have defined a class and we have also defined our objects. For example, here we have our, inside of this class, we have a one function. So the idea behind this function is that it basically does not take any input. Self is basically a self operator, so that's basically related. I'll explain, go into detail about what is this used for. But for now, you can say that this function is basically trying to print the animal sound, and this function is housed inside of this class, right? Now, we just switch the code block. So now, let's say we want to let's take an example of inheritance also, right? So what is an example of inheritance? So we can say that let's say there is a class, right? So let's say a dog class, and inside of this dog class, we have animal. So what we did here was we basically created a class of dog, which is inherited from animal. So we can say if you draw a diagram here, right? So let's say this is the broader set is, let's say, animal, right? And what we did was from this animal, we took all of the functions and all of the objects, and we created another class called dog, which is basically a type of animal, right? So dog is a type of animal. You can similarly have different other classes, for example, cat. So this is another uh, class which is also inheriting from animal. So these are sub classes, you can say, like not exactly a subclass, but rather this class inherits all of the, or basically acquires all of the methods. Methods are basically functions inside of the class. So all of the methods will be inherited or will be taken from. So basically, this class dog will have the same function speak, right? Because it has taken all of the functions from the main class. So now, if you come here and let's say we write something like def speak, so we can basically override our function as well. So that's what we are doing here. So we basically want to modify the original function behavior. So if we do not specify this, then what will happen is we'll just print out this thing, which is animal sound, right? If we don't specify exactly which animal sound we want. So since this is a dog class, so we want to print out bark, right? That's what we want to print out. It's a type of animal sound, but we don't want to print out animal sound since it will automatically be taken into account. So that's what we are doing here. We are basically modifying this function inside of this dog class and saying we want to print out bark. Now let's say we instantiate this class. So we say d of dog, right? And now we do a d dot speak. So what do you think will happen? So what will happen is that this will basically print out. It should print out bark at the end. So it should basically print out this. If you're getting this, then it is correct. So this shows inheritance and polymorphism. Dog inherits animal but overrides the method. So that's what we did here. Right. So let's move on to the next topic, which is called use cases. Banking systems, games, GUI apps. So what do these all have in common? Almost all modern software, from apps to games, rely on OOPS because it is modular, reusable, and maintainable. So to recap and close, we covered the 4 object-oriented programming principles with examples. Next, we'll have computer architecture and organization as the next topic. How computers are structured internally. So that's it for today. Thank you so much for tuning in.